Hello, wonderful people. Now, this is more of a personal episode, um, a rather philosophical take, not much information. To me, space is full of wonder and amazement. I always look up into the stars and wonder how much there is for us to explore. And when I first found out about the size of the universe, the scales of the things involved, my mind was just blown. It was numb because space is huge and it really puts things into perspective. Let's start seeing that. We'll begin by getting away from the Earth, obviously, and soon you'll start to see the real scale of things over here. I quite enjoy doing this. It puts a different kind of perspective to everything. Look at Earth fading away into the distance now, and soon you'll see she'll be joined by a moon. There is the moon. And as we move away from these two, they'll almost appear to be a single object because that's how far we'll be from them. Now, at this distance, the Earth is just a tiny dot, pale blue dot. And I think no one's ever said greater words about it than the late Carl Sagan. And I'll be quoting him now. Look again at that dot. That's here. That's home. That's us. On it, everyone you love, everyone you know, everyone you have ever heard of, every human being who ever was, lived out their lives. The aggregate of our joy and suffering, thousands of confident religions, ideologies, and economic doctrines, every hunter and gatherer, every hero and coward, every creator and destroyer of civilization, every king and peasant, every young couple in love, every corrupt politician, every teacher of morals, every superstar, every supreme leader, every saint, sinner in the history of our species lived there, on a mote of dust, suspended in a sunbeam. The Earth is a very small stage in the vast cosmic arena. Think of the rivers of blood spilled by all those generals and emperors so that, in glory and triumph, they could be the momentary masters of a fraction of a dot that isn't even visible. Think of the endless cruelties visited by the inhabitants of one corner of this pixel on the scarcely distinguishable inhabitants of some other corner, how frequent their misunderstandings, how eager they are to kill one another, how fervent their hatreds. Our posturings, our self-imagined importance, the delusion that we have some privileged position in the universe are challenged by this point of pale light. Our planet is a lonely, lonely speck in the great enveloping cosmic dark. In our obscurity, in all this vastness, there is no hint that help will come from elsewhere to save us from ourselves. So far, the Earth is the only world known to inhabit life. There is nowhere else, at least in the near future, to which our species could migrate. Visit, yes, but settle, I don't think so. Like it or not, for the moment, the Earth is where we make our stand. This is our home. It's said that astronomy is a humbling and character-building experience. There is perhaps no better demonstration of the folly of human conceits than this distant image of our tiny world. To me, it underscores our responsibility to deal more kindly with one another and to preserve and cherish the pale blue dot, the only home we've ever known. We move really far away from our home planet, but we're not even yet out of the system. I'm going to increase our speed to nearly 35-40 times the speed of light. Our speed is currently at 42 times the speed of light. And look at how slow we are. We've not even exited the solar system yet. So I'm going to increase our speed even more. An AU is the average distance between the Earth and the Sun. We're now moving back at nearly 1.7 AUs per second. Even so, we're still slow. But we can say that we are out of the solar system now. Well, now what? Outside the solar system, of course, are other stars, but they won't be visible until we increase our speed by huge proportions. This is our cosmic neighborhood. And as you can slowly start to see stars moving about, you'll notice that there's a lot of these, a lot of stars moving about. But that's not all. Space is so huge that the distances are faster than light can travel. So the images that we see here are actually years old. Light had left those stars thousands of years ago and then reached us, which means that telescopes are time machines. They show us a world that existed before we came into being. And that to me always was wonderful, because nature provided us with a time machine. What else could we ask for? This immense universe is too big to explore for any single person, and with a telescope we can see all of its history, everything together in one mosaic. Just look up at the night sky. As you move behind, the stars are raining down as raindrops, but still we're nowhere close to the next big structure. What might that structure be? The next structure, of course, is the Milky Way Galaxy. Our speed is immense. We're traveling faster than anything can travel in the universe. We're way faster than light. And soon, you'll begin to see something really, really awesome. We'll soon see a Titanic Galaxy, the Milky Way. It's an immensely large galaxy. From end to end, it's almost 100,000 light years, which means that light would take 100,000 years to go from one end to the other. And you'll soon see that the barrage of stars passing by us has stopped. That's because we've reached the galaxy, or the outside of the galaxy, I should say. You can see this arm right there. This is it. This is the Milky Way. And to show it to you better, I'll stop us and I'll zoom out. That is the Milky Way. An immensely large structure, home to billions of stars, billions of planets, and I'm pretty sure there's life out there too, because if there's so many planets, there must be life, right? But if you still don't believe me, this is not it actually. There's much, much more outside of this. Let's see what that is, shall we? We again increase our speed, moving backwards. And all of these individual dots that you now begin to see, each and every one of them is a galaxy, a different galaxy. And you'll soon see the magnitude of the universe. Remember how stars were passing us by when we were trying to zoom out to the galaxy? You'll see galaxies are passing by us now, not stars, and they're passing by at just as large numbers as the stars were. Each of these galaxies has thousands and millions of stars, maybe even billions of them. Almost all of those stars have planets. Can you believe it that there is no life out there? Not me. There's so many galaxies out there that the number of stars in them outnumbers the individual grains of sand on our planet. all the sands, from all the beaches, from all the deserts. You can count each and every one of them, and they will still be less than the number of stars out there, than the number of planets out there. That's how many chances life has. And if it can make it at Earth, a remote planet somewhere in a random system, I'm pretty sure it can make it elsewhere too. The enormous universe is mind-blowing. Stars and galaxies passing by at mind-numbing speeds and mind-numbing numbers. The first time I saw this, I wasn't able to speak for a few minutes because I was just taking in the expanse of the universe, the sheer size of it. There is nothing compared to this, and there will be nothing compared to this, because the universe is everything that we know of. Now I can leave this and not accelerate us anymore. We'll still keep passing stars for a long time because frankly there's just too many of them. To me, this is why I love space. There's nearly an infinite amount to explore, an infinite amount to know. You can never be satisfied, and you don't need to be satisfied because you can always take new stuff in, you can always see new stuff. This simulation right here is a gateway to not limit us by our own technology, essentially. And I can keep talking, but the galaxies won't stop passing us. They'll keep going, and they won't stop. But where I'm trying to reach with this is the edge of what we know. The edge of the observable universe, that is. The universe that we can see in the night skies, that our telescopes can see. But that's not all the universe out there. There's even more to be seen, there's even more to be done. It almost seems endless. And for all practical purposes, it kind of is. There's really no end to this. Look how fast we're growing, but the galaxies keep passing us by, the stars keep coming. Nothing seems to stop it. There is seemingly no stop, but we will reach there as we continue moving faster and faster. We will reach to a point where suddenly no more stars are shown, no more galaxies are shown. That would be the edge of our known universe, the observable universe. The thing is that light is slow. Compared to the size of space, light is slow. And space is expanding. This means that light from some places will never reach us. It will never ever reach us. And this is the edge of the observable universe. It's a huge place, but even this monstrously large observable universe is nothing compared to what could be out there. According to some of the calculations that we've done, the actual universe might be 16 sextillion times larger than the observable universe. Now if you want a scale for that, let's go over to Pluto, because I have a nice little thing that I can show you from there. Here we are at Pluto. The number I just said, 16 sextillion, would be comparable to something like this. Imagine the entirety of the universe, the entirety of what we just saw for the last few minutes. Imagine the entirety of that put into a light bulb, and then that light bulb is put onto the surface of Pluto. The actual universe would be the size of Pluto, and the observable universe, the one that we just saw, would be the size of a light bulb. The scale is literally too big to be comprehended by the human mind. So think it over while you sleep tonight. This is Harsh. Thank you for watching. It's been a great pleasure of mine.